You are given an M by N grid. A small robot starts at the top left and wants to reach the bottom right. The rule is strict. Each step can only go right or down. No going back, and no diagonals. The task is not to find one path, but to count all distinct paths. Can that count be built cell by cell across the grid? The brute force idea is direct. Let FRC be the number of paths from cell R, C to the finish. The answer is F00. At each cell there are two choices, go right or go down. So the recursion naturally branches into a tree. The base case is natural too. Once you are on the last row or last column, only one route remains, so return 1. But while we stay in the interior, the problem keeps splitting. The paths from the current cell equal the down branch plus the right branch. Expand all the way down, and the last layer lands entirely on the last row or last column, so every one of those leaves returns 1. That completes the brute force recursion tree. Notice this. Coming from above reaches F11, and coming from the left reaches the same F11 again. And this is not accidental. The deeper we go into the middle, the more cells are hit again and again by different paths. Repeated subproblems are the signal for dynamic programming. Since the repetition is tied to cell coordinates, we define the state directly on the grid cells. DPRC means the number of distinct paths that reach the cell at row R, column C. For example, the middle cell DP12 equals 3, meaning there are already 3 different ways for the robot to reach it. With that definition, DPM-1N-1 at the bottom right is exactly the total number of paths we want. Now we ask one question. Where does the path count for a cell accumulate from? Since the robot can move down into the current cell, one contribution comes from the cell above. Likewise, the robot can move right into the current cell, so the second contribution comes from the cell on the left. These two parts are disjoint and complete, so the path count of the current cell is simply top plus left. Handle the borders first. The first row can only keep moving right, and the first column can only keep moving down, so all these cells are 1. Start with the first interior cell. DP11 gets 1 from above and 1 from the left, so it accumulates to 2. Continue to the right, and the path counts roll forward. 2, 3, 4. Each cell consumes the results already computed above and to the left. The next row follows the same rule. As the table pushes toward the bottom right, the counts grow because more and more paths merge into each new cell. Finally, we reach the goal, 4 from above and 6 from the left, giving 10 at the bottom right. The answer has been accumulated 1 cell at a time. To recap, put the state on each cell, transition from top and left, fill the borders with 1 first, and the whole table naturally accumulates toward the bottom right.